So this year our Year 10s undertook one of two projects. They could either create a game or compete in our Capture the Flag competition. In either case, they were writing Python code, using text-based code, object-oriented, event-driven programming to create their game or to compete.
So our game is called Into the Gamerverse. The game that we have decided to make is a top-down shooter where we have to defeat all the monsters in a room to move on. The biggest challenge that our group had when we were making the game was just creating the AI to have the monsters follow the player. The game is set out to have 6 levels and a tutorial level with a boss at the end.
The classic game of Capture the Flag. In this game, there's 5 red bots and 5 blue bots. They're aiming to capture the flag on the opposition's side. If they get it over to the original side, it's an instant win. But if there's a stalemate, then there's a point system. So the more time you spend in the opposition's side, the more points you get. And it's 10 times more the points if you're holding the flag. However, if you get tagged in the opposition's side, you get sent to your own jail, and the only way out of the jail is to get one of your own teammates to go to the jail and get you out.
So this is a priority finite state diagram, which is used to transfer between different states in our bots. So the way they work is that they have different priorities for each of the sections, and then if that priority is deemed what the bot needs to do, it switches over to the different section. So for this, P equals priority 1, priority 1, priority 1, that shows priority. If there were more states, there'll be priority 1 and priority 2. For example, if an enemy bot is approaching the flag and the defense bot is the closest bot to the enemy, it switches to attack. However, if there is no more enemies in range of the flag, or you've gotten rid of them, it changes back to driving home, and then once it drives home, it switches back to the wait state, which turns towards the closest enemy when it's at the home position. So these are the 3 states that were on the chart, and this is essentially the code representation of what we have done on our flow state diagrams of wait, attack and home, and how it switches between the different states with else statements.
So our bot starts here on this side of the screen and then moves over onto the enemy side of the screen to start scoring points. If an enemy comes close to our bot then retreats back to safety. Once the enemy then leaves and goes somewhere else, our bot then moves back over to the other side to keep scoring points.